I'm going to present agent-based class design. This is a talk that I gave at CPPCon. It has evolved somewhat. When I first submitted it, I had no idea what the audience at CPPCon was like, so I did a Twitter poll, because that's what you do, right? And apparently they didn't want to see a lot of TMP, but they did want to see a lot of jokes, so I guess they didn't understand that mine aren't usually funny. But yeah, so you know, to introduce myself in a somewhat comical way, here's my superhero origin story. I didn't start out as Odin the nerd. I started out as Odin the hippie. And since we're abstracting things, and you know, I grew up under hippies, well, why don't we look for sort of the abstract hippie, right? Now, the abstract hippie is embodied by Don Quixote, the Spanish knight, I guess, who went crazy and started fighting windmills. Because, I mean, every hippie wants to change the world and wants to, you know, fight for the good and whatever. They're just usually pretty misguided about how to do it, right? And so, you know, there's a gallopy, 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 smack, you know, windmill, and then, well, okay, you know, your heart was in the right place, but now you broke my windmill. And so for sort of a thought experiment, I thought, well, couldn't we, you know, fork the world, because you don't want to break anything, and then, you know, roll back technology 300 years and run tests, and if you did that, well, you know, 95% of the world's population would probably die, right? Because technology couldn't support those populations. So you know, thinking in sort of generic terms like that, advancing technology is the most philanthropic thing you can do with your life. And who does that? Well, nerds, right? So Odin the nerd was born. And the thing is, when you try and sort of advance technology, it kind of follows, you know, this cycle, right? You know, you think of something, you try and implement, and you're like, oh shit, I didn't think about that, I didn't think about that. And then you bang on it, and it's done, and then you show it to somebody, and they go, oh, that's wrong, and that's wrong, and that's wrong. You look like an idiot again, and then you repeat. Right? And the paradox thing here is, you know, if you want to minimize looking like an idiot, the only way to do that is to stop innovating, right? So let's look at sort of what we're trying to accomplish here in this talk. And Roland gave me an excellent segue, because, you know, why was the shared pointer in his talk wrong? Right? Why didn't we just use a shared pointer? Well, it's expensive. Well, why is it expensive? Well, because it's got an atomic ref count. And he didn't need the atomic ref count, because all of those objects were probably not thread synchronized anyway. So these shared pointers would never escape the thread. But we're paying for the atomic ref count anyway, because we don't want a million different permutations of all the, you know, configurable, potentially configurable things in a shared pointer. So we just kind of went for, you know, error on the side of safety and kind of the generic use case and so on and so forth. And, you know, we could just as easily say, well, he wasn't using weak pointers either. Why do we need to pay for, you know, it's just a space requirement, because he only increment and decremented on, you know, use. But why are we paying for the space of the weak ref count in our shared pointer? You know, maybe we're just going to always use make shared. We don't want the user to be able to create a shared pointer with anything besides make shared, because we want that, you know, control struct to be next to the data all the time. Well, we can't do that. We can't take things out of shared pointers interface. So, you know, if you thought about it for about 5 minutes, this is kind of how you would express a shared pointer and decompose into all of its sort of unique, discrete thing. I mean, if you thought about this for more than 5 minutes, you would definitely find that this is probably wrong. But I've only thought about this for 5 minutes, right? So the core idea of decomposing something into its, you know, discrete tasks, discrete abilities, and then being able to make your own. Say, okay, I don't want shared count. I don't want atomic ref count. I don't want all sorts of other stuff. But I do want to be able to just dump a handle tuple into it to build it, right? Maybe I can write that extra ability and just plop it right in there into the shared pointer. That'd be pretty cool if we could do that, because, you know, generally we can't, as library authors, control how our libraries work at this granularity. Right? If either we can write a bunch of components, and then the user has to glue them all together with glue code, or we write something that's probably the best option for most people, kind of a thing, right? And we see this with standard function. Maybe I'm not using exceptions. Well, when can a standard function throw? Well, when it allocates. Maybe I have a custom allocator that never throws. Or when you call it with nothing in it. Maybe I want to set a special handler for that, and then it can never throw, and I can use it with exceptions off without being undefined behavior. Well, I guess that's technically always undefined behavior, but anyway. Maybe I'm working in game design or on some bare metal something, and I don't want to pay for exceptions. The other thing with the standard function is there's at least a theoretical problem, because we don't know the small object optimization size. I mean, I think all three standard libraries agree that if your standard function object, that the lambda you pass in is, the size of whatever 3 pointers are on that architecture or smaller, then it doesn't go to the heap. It just stores it locally, right? And if you have a highly parallelized thing, and your objects are all 3 pointers in size, and then you switch standard library implementation. I mean, this is never going to happen because it's going to break the world, right? But there is the theoretical problem of, you have vendor lock-in, because, I mean, it isn't broken if it's, 1,000x slower, but it is broken if it's 1,000x slower, right? And, maybe I have objects that are 4 pointers in size, right? Maybe I just can't make them smaller, and I still don't want to go to the heap. Well, pretty much every company in their code base has something like a standard function that's not standard function, right? And I follow the mailing list in the SG14 working group. We work on pretty much everything which is resource constrained, like high frequency trading and game design and bare metal, and it's kind of where I try and be useful. But the in-place everything problem is, okay, I have small string optimization. Why can't I have a small vector optimization? Why can't I set the size of small string optimization? Why can't I make a vector that can't grow past x so I can use it in a const x per context, right? Why can't I do x that's slightly different than what the standard library does? And there's just a gazillion proposals like this, because everybody rolled their own because they didn't quite have the use case that standard vector or whatever was made for, and now they want it in a standard library. Well, it's kind of part of the same problem. But this generic problem, if we look in other domains, and I'm going to be heckled here in a minute, because there is the one of the troll tech guys here, and he's actually occupied. Yay! He's not going to heckle me. Yeah, I mean, if we look at Qt, right? What's one of the problems with Qt? It's out of respect. I'm not saying Qt. I usually say Qt. So Qt. Performance is sometimes a problem, and the performance problems of Qt GUIs come from the fact that they went a different path. They said, okay, you can generically compose things, you can generically combine all sorts of things, and this is a very powerful concept, and it works very well, and but they use virtual functions to do it, right? So if we look at how this dialogue is built up, for those that are not familiar with Qt, you kind of have a tree or a hierarchy of widgets. We're going to have probably a VBox layout with something down below and something up above, and then the something up above is going to be divided by a grid layout, and then some of those are going to be subdivided again, and then if we look at this widget up here, this is probably a composite widget of both a label and a text field, and then but under the hood it's a text field and a label that are just bound to each other. And if we get some kind of events from the operating system, like resize or repaint or whatever, they're going to propagate to the root, and it's going to pass them on to its children, and it's going to pass them on to its children and their children and their children, and so on and so forth. And okay, if it's a repaint, probably all of them have some visible something they need to repaint. If it's a resize, well, this doesn't care. It's fixed width, right? So that event didn't really need to get propagated all that way. And if you look at things like, keyboard or press events or clipboard events or whatever, they don't go through this nicely awesome propagation system because it would be too slow, right? Because probably none of this cares about the clipboard, right? But the compiler doesn't know that none of this cares about the clipboard because it's behind, maybe a string of 20 virtual function calls. So, if we want to take the virtual function calls out, there's obviously the potential there. I mean, this dialog box is known at compile time, right? I'm leaving out the other way to make cute GUIs. But anyway, if we're looking at sort of a widget-based model, then at least there is the potential there to make this statically linking and take away all of the virtual calls. And we could express it in much the same way that you express sort of compositions of cute widgets. You could also make local versions and then copy them in, or just one giant hierarchy, just putting widgets in widgets in widgets in widgets, and building this tree. And those of you who know sort of TMP recognizes expression templates. This is kind of the same tricks that Roland is using for his SQL stuff, or anything that's doing anything magical under the hood is using, essentially, right? but what is TMP? This seems to be a pretty advanced audience. But at CPPCon there were a lot of people that didn't know what TMP was, and for this talk, I'm talking more about abstraction mechanisms, about compositions, and this is built on a lot of TMP. But you don't really need to understand TMP to get this. So either TMP stands for template metaprogramming, which is a Turing-complete general-purpose code generator built into your compiler, or it's Tabia, Marie, and Powell, 3 magical unicorns that live in your compiler and do whatever the library author told them to do, right? The joke is these are 3 of my coworkers. But so what I actually, where I first met this problem and decided to try and solve it is actually embedded drivers, as in drivers that run on microcontrollers, because they're, wasting any optimization potential is problematic, because stuff costs money. If Logitech can save a penny a mouse, then whoever did that is rich, right? So because C is obviously the more efficient language, microcontrollers are written in C. Before you all hang me, this is. Yeah, but so there is another way to get at this problem, right? We can either say, okay, what's the common case, what's the safe case, and leave some optimization potential on the table, or we can say, oh, we should be able to compose things generically and build it on top of virtual functions, leaving arguably more optimization potential on the table, or we can do the microcontroller way and just spit all of the internal details into the public interface. I mean, notice step 7 of a 17-step Hello World tutorial, right? Like, this is not a library. I mean, it tries to be a library, but it's not saving me any intellectual overhead. It's not saving me any time. I mean, everything except for like the baud rate and what pin it's using is default. But I have to write it anyway because this is C. This is essentially the inherent complexity. All the rest, not just that slide, but all the other steps were artificial complexity. They should be in the library. And your question is, can we make this work, right? By the way, UART is like a subcategory of serial ports, if you're not like a hardware nerd. And the key here is, now that we got rid of all of the noise, we can see, oh, this is a blocking call. Like, who noticed that on the previous slide? No hands, right? I mean, it's right down there, obviously. So if we get rid of, the artificial complexity, stuff gets correcter, productivity goes up, so on and so forth. But can we make it 0 cost, right? And I actually, Alexandrescu's Modern C++ Design was my first C++ book because I hate myself, I guess. And he presented the concept of policy-based class design in that book, where you can compose things generically and everything ends up statically linking. And so this is a photo that my wife took of me about a year ago. She really captured the mood. Yeah. Anyway, so yeah, I wanted to build embedded drivers using policy-based class design so that the user can put in just what they want, and it all statically links, and everything's super efficient, and we have a reason to not use C, which is always a good thing. Sorry if anybody's, yeah. So yeah, on our sort of scheme of how the world works, we're here, right? Implementing it was a lot harder than I thought because there's lots of problems. One of the biggest problems with policy-based class design is essentially if you rely on anything being communicated between the policies, it kind of has to be in the public interface, or you have to start rolling your own and building on top of. And Alexandrescu acknowledges in his book, what, 16 years ago now, and I guess that's kind of where it stopped. The other problem is variadics, which weren't even possible at the time. If I'm extracting a USB driver, I can have a variadic amount of endpoints, at least up to some upper limit that the hardware dictates, right? So I can be not only a mouse, but also a keyboard, right? I could theoretically also be a bunch of other stuff. And we don't see that in practice very often, which maybe is because you kind of have to roll your own. Libraries only support one thing per USB device, usually. Yeah, so if I have like a variadic pack of policies, and I have some other policy trying to talk to them, then I have to start rolling my own TMP code to do that, right? Like, the one-to-many kinds of calls. And that's kind of defeating the whole purpose. But I was young and naive and carried on and built like a USB driver and a couple other drivers and presented them to some people at the after party at our MBO conference. The MBO conference was built out of the idea that I wanted to go to a conference where people talked about microcontrollers and library abstractions and zero cost stuff, and I wanted to have beer. And there wasn't that conference. Like, the embedded world is basically a, Dauerwerbesendung, whatever that is in English. I mean, it's a show where people, marketing people come there and pretend they know what they're talking about, right? And if you look for an engineer there, sometimes you find them. The smaller companies sometimes have actual engineers, but if you're looking for an NXP engineer, forget it, right? And that's not the conference that we wanted to do like experts talking to experts. We put it on the weekend so that people that didn't really want to be there, they just didn't want to go to work, wouldn't come. And so yeah, there's another one coming up in March if you're interested. But I was talking to Joël Foucault, and the Bridgend and Boost SIMD author. And cool thing about him is he's very direct. And he basically said, okay, Odin, you screwed up because I can't read your code, and it's not about me. No one can read your code. You won't be able to read your code in the future. And he was right. So, in the sort of hippie metaphor, gallopy, right? And, this is part of my giant pile of code. I don't know what it does anymore. And I did inspire some artists, right? I mean, he got something out of it. But so why did I fail, right? Like, on some generic level, the problem was that I built this toy, which looks generic unless you kind of zoom out, and then it's not generic anymore, right? You have a certain amount of things you can put in it. It's basically a strategy pattern, right? I have a thing that you can swap out with another thing, but the world is not abstractable in strategy patterns only. I need Legos, like the old Legos, where you can build anything, not where you can build like one scene from Pirates of the Caribbean, and then you have to buy new ones. But that's a different topic to rant about. Another thing I'm super bad at is naming things. So I figured this time I'm gonna follow a different strategy, and I'm just gonna steal names. You know, there's this theory in you know, Industry 4.0 manufacturing, where all of the tools, all the robots, all of the production lines, and whatever, are going to know their capabilities, and then they know their requirements to build some abstract product, and they're just going to kind of self-assemble and build a product from some adjectives. And the thing is, like, I kind of speak my mind, which gets me in a lot of trouble a lot of times. So I'd said, well, this is great because academia can just like go to town on this and no one's ever going to actually do it. And I said that a week ago at Cisco, and they said, hey, we're building that. I'm like, shit. But it turned out in conversation that it's definitely not this. The idea carried over, the terms carried over, but that's sort of, because, you know, academics, not all academics, sorry to you guys that are actually productive, but many of them have found a way to hack this system, right? They go to here, which I call the PowerPoint line. And then you don't look like an idiot because the engineers do this part, right? We're the ones looking like an idiot. So let's actually look at sort of what I'm, you know, proposing here. You know, the theory behind it, you have what's called an agent. Agent knows its capabilities, knows that it provides to the rest of the world, knows its requirements that it requires from the rest of the world, and this is not like a valid set of agents because the requirements, you know, shown by sockets here, are not fulfilled. It provides a few things, needs a few things, but, you know, Agent Smith alone, you know, random agent name, he needs like Agent Jones and that weird squiddy thing. Sorry to the people who didn't see the Matrix. And this is now a complete set because all of the sockets have balls, right? All of the requirements are met. There's some abilities that are not needed. That's not a problem, right? And if you look at sort of the code, this is kind of how I'd like, you know, this is the interface I'd like to have, right? I have different things. I don't want to have to write all the glue code that I write in policy-based class design, because policy-based class design, every different thing needs a different policy, which is basically just a name for all the glue code. I want no glue code. I want the glue code to be, I want the agents to know what they need. I don't want the magical unicorns to write all the glue code, right? So, you know, the other problem that we had with policy-based class design was everything being the public interface. So we're going to do this differently. We're going to say, okay, this is an arena with all the agents in it. They can talk to each other. They can find each other, you know, based on abilities. And the outside world can't see that. It's encapsulated. And then we have, you know, from the outside, we have interface classes which talk to the outside world and can talk to the agents, right? So we can find, you know, we have absolute control over what the public interface looks like. And so, you know, looking at actual code, this is an agent. There's essentially no requirements on an agent, right? Agent can be anything. We need to map abilities to this agent, which we do from the outside, so that you can use like other people's classes and make them into agents, right? So you know, the way to do that is you basically wrap it. You say, okay, this is the agent I want to wrap. Well, I'm going to make an alias to agent with abilities. This can be a variadic list of all its abilities, and then its type, and then that's the agent that I put into the agent composition, right? So I'm mapping abilities to this agent. And you know, if people know about concept maps, kind of the failed attempts to make concepts different in C++ than what's proposed by most of the committee, this is basically concept maps, right? You know, from the outside, I can say, oh, that thing that can do X, rather than being a syntactic requirement. It's a semantic requirement that I'm associating with the agent. And if the public interface classes, they have a little more sort of unicorn interfacing stuff. They take one template parameter that they have to derive from. You just, you know, learn that as a library user, right? But because they derive from it, they have a bunch of magical functions, which come from somewhere in that base class, where I can just say, okay, every agent with this ability execute this lambda. Right, so from a public interface class, I can talk to the agents. The agents can also talk to each other. If I'm in the public interface class and I want to call a function an agent, and to handle that function, it might need to call other agents, I can just pass it this agents thing. I mean, it's either like a bowl of unicorn soup, or it's a pointer with a bunch of template parameters around it. Whichever model you'd like, right? I don't just have the ability to say for each, because I'm also expressing a contract here. If I say for each, then this composition will support multiple instances of something that fulfills that has that ability. If I say, for each is the 1 to n case, I also have a 0 or 1 case, right? I can have, in my 0, 1 case, a fallback in case there aren't any, right? If he doesn't find anyone to talk to, then anyway. I can say there has to be exactly 1. And I just, as I said, I'm bad at naming things, but, there's a name for each one of these concepts. So if I want to compose all of these things, right? There was that compose function, if you think back 10 slides. This has got to be a function that can generically generate glue code for any set of agents. However, it's, at least the compose function itself is just a factory function. It could be in C++ 17, it could be a constructor. Since we're aiming at C++ 14 and up, it's a factory function. Basically, all it does is take all of the agents you pass to it, and the public interface classes, and whatever else you pass to it, puts them in a tuple, and passes that to this composed object type, its constructor. So this is our private arena, which all the agents are going into. They're just put in a tuple. They're not base classes that have to be public, as they are in policy-based class design. If we look at this composed object, well, here we start to see a little bit of the template metaprogramming, right? And the way to spot template metaprogram if you're not a template metaprogrammer is what's called the unicorn call syntax. You can see the pointy horn operator on both ends of this thing. That means we're talking to the unicorns. So data is just a member. This is actually conceptually what we're doing. It's not actually what we're doing because the standard tuple implementations from the standard libraries suck. But we also, these magical functions that were in our base of base of base of base, we're declaring them private here because they used to be protected so that all the interface classes could access them. We don't even want anybody deriving from us to be able to access them, so we can make them private. But what the unicorns are doing here is they're filtering out all of the classes that are interface classes, and they're taking the first one and passing some magic base class to it as its first parameter, which it derives from, right? And we pass that to the next one, so the next one derives from that. So we have just this chain of all the interface classes. So the top level composed object derives from first interface class, second, and so on and so forth. Way down at the bottom, there's the sort of magic base class, which provide the for each and so on and so forth functions. It has the type of the most derived, so it's the curiously recurring template pattern just stretched out, right? So we can add to the public interface along the way. So this will cost you, no space and no runtime overhead, at least after the optimizer's done with it. Yes?
What about compile time, though?
Well, actually, doing this is about an order of magnitude cheaper than doing this, because it's a very different implementation. It's actually blazingly fast. We'll see the limits soon, but this is using the Quasar MPL library. Oh, sorry, repeat the question. What about compile time was the question. And it's good. We'll see where it breaks down soon is the answer. Because this is using the Quasar MPL library, which was my last project, which is painfully inching its way towards the boost review queue They already have the name MPL, so I'm going to call it Boost Tacit Metaprogramming, because that's Boost TMP. And that's anyway. There's some other talks on this. It's like 2 or 3 orders of magnitude faster than Boost MPL from the compile time. Depends a little on the use case. Anyway, so yeah, I had sort of the construct destruct not shown here. If we look at those, there's potentially one more problem with this generic composition. What if the initialization of one agent needs to do something with a different agent, right? What if I have one agent that needs to allocate something on initialization? It doesn't know how to do that because it could be either in some local buffer or on the heap, depending on what the other policy is, or the other agent is that the user passed in. And so how we did this, I mean, this is if you're not in the unicorn camp, if you're thinking about this in template metaprogramming terms, it's hard to make them be able to communicate with each other, because in the constructor, the point of instantiation of a constructor is before this type is known, right? And this is also a problem in policy-based class design, that initialization is just hell, right? But the way we solve this is this type is already known, and all we really need is this type and not the entire type, because what the agents are actually working on is other agents. They're here in this arena. They're not, this compose type adds a public interface, but we don't have to go through that, right? So it's two-phase initialization, which is terrible, obviously, but it's definitely better than zero-phase initialization, right? I mean, we could theoretically make it n-phase initialization. That would probably be even worse. So yeah, it's here we start to see some of the critique of this approach, but there's nothing that does it better, at least that I know of. We're going to have to go real fast through this example. This was another thing you can use this for is generic text parsing is another example I pulled out, because one of my coworkers came to me and said, I'm getting this weird linker error on my microcontroller, and I don't understand it. I narrowed it down to essentially the Stack Overflow example, which look how often it's been upvoted. This has got to be right. Why am I getting a linker error? I'm sure I got Boost right. I'm sure I got everything else right. And it turned out the linker error was saying I'm out of memory. And the funny thing is, like, if you comment out these 2 lines, then it used, I think, 30 bytes of RAM and, like, I don't know, 100 bytes of flash. And I had 128K of flash and 30K of RAM. And if you comment these 2 in, it's full. The reason for that is 2 upper, what the uppercase letter is depends on the locale. The locale is obviously a shared object across threads, pulls in all the synchronization stuff. For some reason, because locale also has stuff to do with date time and all that other stuff, it pulled in all that. It basically pulled in the entire libc, and I'm going to rant about libc some other time because I want you guys to get home on time. So anyway, this is basically 2 upper. Oops, sorry. Like, it's not that hard to write a 2 upper if you don't care about locales. And if you've got a microcontroller application, like if you make furnaces or something, if you make furnaces, you don't need like Turkish and Spanish and anyway, it's not cold there. Yeah, no, but you know your market usually, right? I mean, you can't put a whole ICU library into a microcontroller, so you want more fine-grained control. You're also probably not multi-threaded, all that other stuff. Maybe you don't want just the American letters, right? American letters, ha, ha, ha. There are letters now, America first. No, you want, some of the other locales. So if we expand this interface a little bit, because there are languages where one lowercase letter turns into 2 uppercase letters and things like that, right? Especially with Unicode, you know, an A with dots is going to be an A with dots, and then maybe, or I guess A is the wrong example. I guess turns into 2 Unicode symbols and back into 1 uppercase, lowercase. Anyway, in Turkish at least. So if we have basically 2 ranges, I eat something out of one range and spit something into the other range, and I return whether I actually processed something. And then we can chain these. We can say, okay, Swedish is American plus Latin 1, right? And then we can just keep chaining things onto there, and it'll just go through in a priorities manner and find the replacement that matches, and we're all good. We could also do, you know, URL encode, decode, anything, right? Essentially, you could build a whole parser on top of the interface, composable parser kind of a thing. We could also format strings with this, right? You have an agent that spits out this number and an agent that spits out that number. Maybe they add to the public interface so you can actually set the numbers and just compose all these string manip pieces into a string manip library that doesn't have, you know, support for %z. Who knows what %z is? Size t in printf. You don't need that on a microcontroller, right? We shouldn't have to pay for it. But coming back to the driver example, now that we kind of understand what's going on behind the scenes, under the hood, this is writable, right? Like, you need a user-defined literal that will turn this into something. TX is something with a, you know, some tag with an overloaded with a copy constructor that doesn't actually copy, that just adds meta information. You know, UART1 will optionally require you know, getting baud, getting I don't know, parity. We didn't say anything about parity. That would be the fallback. This is suddenly pretty implementable in a way that other people can read it, right? If we want to extend this class as a user, right? Maybe my library didn't have support for Autobot, which basically tells the UART to look at the bit stream, and the shortest thing it sees, that's the bit width, right? Because there's nothing smaller than 1 bit length on the bus, right? So, you know, to turn this on, we set some bit in some register, and then when it's done, when it actually is calculated the baud, we get an interrupt. And there will be some status bit that the interrupt was about Autobot. Now, this is a very good example if you're trying to beat C, because the compiler doesn't know that that 1 bit that we set in some address means that this other bit in this completely other address in some weird interrupt service routine entry point will never be true, so it can just optimize away that whole branch of handler, right? The optimizer doesn't know that. And unless we actually spill absolutely everything into the public interface, or use macros, or, you know, just some total hacks, we can't express that in C. But we can express the fact that we know that in C++. Because, you know, if nobody ever sets that bit, that interrupt will never fire with that status bit. So we can take out the interrupt service routines. I built a bunch of other infrastructure to actually, you know, talk to the underlying hardware registers. I talked a little bit about that last time I was here. You know, combined, as far as, you know, apples to apples driver comparisons, were statically typed and often an order of magnitude faster than C. You know, C from the chip manufacturer. Right? So not just somebody's C, but C written by experts, by people who live in or work in the same building as those that design the hardware, right? So yeah, C++ is the faster language. But yeah, anyway, yeah, we can just skip over this because I see we have a bit of time constraint. Another problem that you have as soon as you start to templatize everything is vocabulary types, which you also mentioned in your talk. If I have some weird type and I want to work on whatever that weird type is in another translation unit that probably shouldn't know anything about all these templates, it's nice to be able to call it a standard vector or some, you know, known vocabulary type. And this is where sort of type erasure and the whole virtual function stuff kinds of creeps back in, because you probably don't want your entire project or team or whatever have to know about all these composition possibilities and all these all the permutations this type can take. But there's a really cool library called liberase from Gasper Asman, which is basically a composable interface library where you can take all sorts of little bits. You could say, okay, I want my type erase type to be copyable. I want it to be movable. I want it to do this and this and this and this. And it builds you a sort of concept-based polymorphism style, the Sean Parent approach to polymorphism from the outside as a wrapper rather than from the inside as a base class, right? And since we know all the bits that are in our public interfaces anyway, we can add a little bit of unicorn symbols to our public interface, and it will know how to type erase this thing, right? So I can say erase this interface of public interface foo and bar, and then compose of foo bar anything. Adding more functionality will be not accessible through this interface, but we can type erase these compositions in a generic way, right? If we go back to the Qt example, I can take this whole dialog and put it behind a widget interface, right? And easily, like this is all the code, right? But if we come back to the Qt example, this again, we kind of understand how this works under the hood now, right? These are all agents, and the trick is that a composition of agents with its public interface can in turn be an agent of a higher level composition, right? So you can build a whole tree of them. So my VBox layout is to its towards the root of the tree. It's public interface, it's a widget, but on the other side, it's a composition of all the things that are in that VBox layout, plus a little bit, right? So we'd build VBox layout would be a factory function that would take all of its child widgets, add some abilities, whatever the public interface of a widget is, add some of its interface and event forwarding stuff, blah blah blah, and then all of its child widgets are just agents in its arena. This has the advantage that as long as you don't type erase anything between the root and the leaves, the optimizer sees through this, right? It can see, oh, that guy doesn't care about resize. I'm just going to eliminate that entire branch. It also means that you push the limits of template metaprogramming, because in a realistically complex window, you could have hundreds of, not thousands of widgets, right, all nested in this hierarchy. And back a year ago, people thought I was crazy when I was benchmarking Quasar MPL up to 8,000 types in different operations like sort and things. But here you actually may reach that limit. I mean, the reason why we didn't, why it was crazy to have a metaprogram that took a list of 1,000 types is because that would take forever. But that's a moving target, right? Like, it's not that we don't have more complex problems. It's just we cannot solve the problems because compile time gets in the way. So yeah, we can work on a hell of a lot of widgets before compile time starts to slow down, because this is where Quasar MPL really shines. I mean, if you're not familiar with it, the most important thing to say about it is that we leverage aliases rather than type instantiations. And calling an alias is way faster than making a new type. It's also hard to make decisions in aliases because they're not partially specializable, but you can get around that by nesting them in classes which are specializable, and so yeah. Anyway, there are a few talks about this if you're interested. If we want to make a composition that is a shared pointer, we run into another problem, because how does the library know that this pointer needs to go into that? It doesn't, right? We can't just pick and choose out of the public constructor and put them in widgets. Cool thing is that I mean, we could use like the big fucking hammer solution and just instantiate everything, at which point we can construct, because you know, an agent is just a value going into a tuple. We can construct that thing from the outside. We do get around that, you know, the initialization problem that we have in policy-based classes, and it just isn't elegant, right? And we can get cute and say, okay, I'm going to make like a name parameter kind of a thing and do all the dispatch under the hood. But luckily, there is Gasper Asman, whose new library project is what's called production guidelines, where, you know, he's kind of getting at the problem that everything in the standard library essentially has 11 to 14 public constructors, because that's the pain threshold of the standard library, not for any other reason. Like, there are more permutations of things that you could put in there. And if you wanted to tell somebody how to implement all of the permutations you want, you could express that algorithmically, right? Like, it's you know, the last thing, if it fulfills allocator traits is allocator or whatever, that's the allocator, right? I mean, you know, first thing could be range, could be 2 iterators, could be value, whatever, depending on what it is, it's going to be interpreted as a different thing. And I guess this idea came from Sean Parent years ago, who gave the example of a function taking height and width. Why can't I call that with height and aspect ratio, or width and aspect ratio, right? It's the same thing. And with so-called production guidelines, you can actually express that in TMP. There's like a buggy HANA implementation that we did as a library in the week at last C++ Now. I hope that he submitted this to C++ Now. At CPPCon, I just said he was submitting it to C++ Now without ever asking him beforehand, and he was mad at me at first, and then he said it was a good idea. But anyway, so we are probably going to solve that problem. But since we have some cute people here, we could actually look at the cute example a little more. Well, I had a lot of slides. Let's go back to the cute example. We could look at the cute example in a little more detail. There we go. Okay, so this widget, when changed, will update this text. And this text, when changed, will update this widget, right? It's like the signal slot mechanism where you can connect these things at runtime, sadly, to talk to each other whenever they're changed. And again, this is, I think, at least 3 virtual function calls to get from A to B. But, and probably a cast mesh because it's on the heap and blah, 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 blah. But if we think about this, okay, all of this is known at compile time, right? We have a tree of everything in this dialog in the form of templates. Like, we can do poor man reflection over this whole tree, right? We can say, okay, I'm here. I have some named signal slot connection. I'm going to start at the root and go through the entire tree and find something else that has the other end of that named signal slot connection. And I'm just going to call it directly, right? We can get rid of the virtual function calls and the fact that something's on the heap and blah, 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 blah. This starts to break down as soon as you have widgets that could be there or not be there, right? Like, the signal slot mechanism is not just out of pure laziness or pure non-template metaprogramming existing when Qt was developed at about the time of my birth. But it's there because you can also reconfigure this dynamically at runtime, right? And you would want to do that if you had maybe a widget that's sometimes visible and sometimes not, right? You could also express that widget that's sometimes visible and sometimes not as a variant of possible widgets. In which case you could, when you reflect over this whole thing, check which state that variant is in and dispatch or not. As soon as it's truly behind a type erased interface, then you would have to fall back to sending an event through the whole event system and blah, 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 and virtual function calls. But you could still do that, right? Like, I haven't put in the 100 man years or 1,000 man years or whatever we need to re-implement Qt, but like, you could make it a whole lot faster and smaller. So yeah, in the sense of academic tradition, I'm going to declare victory and drop a paper. It's going to take way too long before I get to that slide for it to be funny. But no, I'm not. I'm working on this. Oops, it's even gone now. Yeah, I'm actually working on, or at least I submitted a paper to CPP now on sort of in a event component system. Kind of like this Qt example. You have these same kind of event filter compositions in a lot of server stuff on microcontrollers and any event-based system. And a lot of the time they're either generic, composable, and slow, or they're just this pile of black magic voodoo edited by a guy with excellent job security because they need to be fast. And I think we can make them both fast and generic and readable. So, yeah. Questions? Yes, in the back.
State machines. Have you heard of MSM?
Yes. I've used MSM. Sorry, state machines, have I heard of MSM? You're probably going somewhere with this. Or, yeah.
So we were using a project where we were using MSM. So it's a metaprogrammed state machine library.
Yeah.
From Boost. And we had basically the compiler fell into our feed in a very little complexity.
Yeah.
When it comes to what you can express with state machine, especially when you started to use concurrent states and a lot of history and so even which you can imagine as a person with a state machine, and we try to compile it, we needed we could drink a lot of coffee because of it. And then the linker was another imagination. And the question is, when it comes to new C++, C++17 with the variadic templates and the new compiler toolchain, is it possible to rewrite that library, which is more faster, and provide a way where, because what was ending up to do in the end, to break the compile and runtime aspects. I wrapped the whole thing into another library where I can say this goes into compile time, and this is the point where we create actually separate compile units to be able to deal with the complexity which we need.
Yeah. The comment was that old Boost is slow. I'm not just going to say Boost MSM, but most all of old Boost that had any TMP component was slow. And you could check out Chris Uziak's SML. It's pretty similar to Boost MSM, but orders of magnitude. Like you can have thousands of states, and I think that was slated for adoption into Boost, but I guess Chris just said, "Oh, other sexy project," and then that probably a couple more times. I will get on his case. He should get that into Boost. He's actually going to be speaking at EMBO about state machines. Yeah, I think actually I will also revisit that sort of topic of fast state machines with a little more sexy definition strategies than Boost MSM, because in a lot of these event filters there are also state machines running, and it'd be cool to just plunk them right in there in the tree. Yeah, that's not very high on my list though, so probably bug Chris Uziak, tell him to put it in Boost. It actually works pretty well already. Like it's a pretty well implemented library. He did all the TMP himself in the library, which means it's portable. It doesn't rely on any of my stuff, but it probably could be another 3x, 4x faster. So yeah, any other questions? Okay, thanks everybody.